Hello, good morning. This is Naz from NB Network Lessons. Hope everyone's doing okay and in festive mood. My today's topic is going to be Calculus Lesson 45, which is basically what I'm going to do is I'm going to introduce you hyperbolic functions in terms of the true sine functions. Okay. So basically in my last lecture, what I did was that I showed you what is a trigonometric function. So let's go ahead and recap that real quick. So this right here, let's say we have a circle, okay? Let's say the radius of this circle right here is 1, okay? It's 1 feet, 1 inch, whatever you want to do it. Then I can say x square plus y square is equal to 1. What is x square? X square is just this part right here, right? All right. And then y is going to be basically this part right here. So what I'm saying is that if the radius of the circle is 1, then x square plus y square is equal to 1. So that's trigonometric function. Now, real quick, and I can write this also as cosine square x plus sine square x is equal to 1. All right. So now let's look at hyperbolic functions. So hyperbolic functions, this is a recap for lecture number 44. So we have something like this. All right. This is like a hyperbola and they're quite similar. In this case, in case of a circle, I have x square plus y square is equal to 1. In case of hyperbolic function, it's going to be x square minus y square is equal to 1. All right. Or I can write down this as cosine hyperbolic square x minus sine hyperbolic square x is equal to 1. All right. So this is basically kind of like showing you, how a trigonometric function looks and how a hyperbolic function looks. Now, I'm going to show you these formulas right here. Okay. Now, these formulas were solved by mathematicians long time ago, and they might or might not be in your book, but solving these, how we get these is beyond scope of my lecture. So I'm just going to show you sine hyperbola x is equal to e raised to power x minus e raised to power minus x over 2. This is basically the true form of hyperbolic functions in terms of sine, cosine, tangent, cotangent, secant, and cosecant. So you have to basically, if not memorize, they will be given to you in the test. And then in the red right here are the derivatives. Okay. So the derivative of sine hyperbolic x is cosine hyperbolic x. Derivative of this is sine hyperbolic x. Tan hyperbolic x is equal to secant square hyperbolic x. So take a screenshot of this. Okay, you don't need to memorize these because, who's going to remember those? But I'll tell you what, once you become a mechanical engineer, you become a civil engineer, you're constructing a bridge, you're designing a crane, you're going to use these. All of these are going to be used because you're going to run across a design of a crane, for example, in form of a hyperbola, in form of a circle, in form of a function which varies, who knows. So you will, these are not just formulas I'm writing on the board for you to pass the exam. These formulas will actually help you when you become civil engineer, mechanical engineer, and you're designing cranes, you're designing roads, you're designing rockets, you're designing, whatever. These are useful. They're going to be used. Okay. Just wanted to let you know that. So in my next lecture, what I plan to do is I plan to come back and solve some problems. Okay. and show you the mathematical calculus application using and then finding out solutions of few problems. All right, hope you enjoyed it. I'm going to come back and we're going to go through some problems and have fun. Take care of yourself. Bye-bye.